Hello everybody, my name is Karthikeya from CSCE. My topic is evaluating critical security issues of the IoT world and of present and future challenges. So, in the next future, the Internet of Things paradigm will involve billions of smart devices with processing, sensing, and actuating capabilities able to be connected to the internet. Integrating social networking concepts into the IoT has led to the social IoT SIoT concept, which enables people and connected devices to interact, facilitating information sharing. However, interoperability, security, and privacy issues are great challenge for IoT, but they are also enabling factors to create a trust and interoperable ecosystem. In fact, not solving these issues, the SIoT paradigm will not reach enough popularity and all its potential can be lost. Security issue is emphasized by the lack of standards especially designed for devices, limited resources and heterogeneous technologies. In addition, these devices, due to many vulnerabilities, present a fertile ground for existing cyber threats. Threats in IoT system model. A generic IoT system can be fully represented and described by using three main key layers: perception, transportation, and application. Each of these system levels, summarized in figure, has its own specific technologies that brings issues and some possible security weaknesses. In fact, the security problems of each layer are analyzed separately by looking for new robust and feasible solutions. Let's see, we can see the application layer and transportation layer and perception layer. Here the perception layer is the first layer and the transportation layer is second layer. The application layer is the third layer. In the perception layer, we can see the main threats in the perception layer are physical attacks, impersonation, DOS attacks, routing attacks, example VSN, RSN, and data transmit attacks, VSN, RSN. So these are the main threats in perception level, and the main threats in the transportation level are routing attacks and DOS attacks and data transmit attacks. And the main threats in the application layer were data leakage, DOS attacks, malicious code injection. So coming to the IoT security, the security in IoT devices is often neglected or treated as an afterthought from the IoT manufacturers. This is mostly due to the short time to market and cost reduction driving the devices design and development process. The few devices that support some protection usually employ software level solutions such as firmware signing. In this session, we will discuss about the design of security techniques for IoT system and devices, also highlighting the difference between traditional IT security. The first one is the uh, CIA model. The CIA model is about confidentiality, integrity, and availability. So this is one of the model which we can uh, use it to use it for the security, and in the confidentiality, the user can have confidence on the data leakage, which means the data will be confidentiality, and integrity means the data cannot be modified, and availability is data will be very available. And and coming to the next model is IoT security. So we can compare the IoT security to the traditional security, IT security. The traditional security, add-on security will be there, but in IoT security, the built-in security is there. And in the traditional in the traditional IT security, there are complex algorithms, so it's very difficult to understand. In the IoT security, lightweight algorithms for resource constrained devices, and in the traditional security, the user will be controlled. In the IoT security, privacy issues, IoTs often collect automatically user private information, and in the normal The next one is small technological heterogeneity. In the IoT security, the large technical heterogeneity and thus all large attack surface. So there are many security guards in IT security, but there are few in IoT security. And the IT devices are located in closed environments in traditional IT security, but in the IoT security, the IoT devices are located in open environments. So the third one is multi and cross layer security for IoT system. According to the presented IoT system model, security must be developed at different layers. Here we describe that appropriate security policies and strategies which provide certain references value for the practical application to IoT scenarios. However, the security requirements for IoT cannot be achieved by simply putting specific solutions from each layers together. In fact, it is necessary to consider IoT systems as a whole system, and security can be thought of as a chain that is robust as much as its weakest link. Therefore, to improve IoT security, we also need to have some cooperation between different layers by designing security solutions for cross layers usage, overcoming heterogeneous integration issues. In this scene, interoperability can become one of the enabling factors for IoT security. Thank you.